orbiter access arm. This is the walkway used by the astronauts to enter the orbiter. In case of an emergency, it can be put back into position within 15 to 20 seconds. T-minus 7 minutes and counting. T-minus 4 minutes, 25 seconds and counting. Liquid oxygen now flowing back through the main propulsion system and back to the large storage tank on the pad to cool the engine system slowly down to 270 degrees below zero, so it will not be shut. If the engine valves which control the purge fail to open, there's an opportunity to try that once more and then hold it 2 minutes and 30 seconds for an additional try. Normally at this point the range safety destruct devices are armed, but that's not necessary for this test. T-minus 3 minutes 30 seconds and counting. The elevon, speed brake, and rudder move through pre-programmed patterns to ensure they're capable of doing their job during a flight. Engine gimbal checks of the main engines are also underway to check their ability to steer the vehicle during flight. For the flight readiness firing, they only move from the start position to the launch position. Coming up on the 3-minute point in our countdown. T-minus 3 minutes and counting.
Let's just go for ET-LO2 pressurization.
Pressurization of the liquid oxygen tank underway, and the main engine gaseous nitrogen purges have been terminated, and the gaseous oxygen vent arm has been commanded to be retracted from the top of the external tank. The ground launch sequencer will check that retraction at the T-minus 37 minute point. T-minus 2 minutes 25 seconds and counting. Fuel cells are operating on their internal reactants.
T-minus 2 minutes.
T-minus 2 minutes and counting. And liquid hydrogen tank flight pressurization has begun. At the 1 minute point, the joint heaters on the solid rocket boosters will be turned off. T-minus 1 minute, 45 seconds and counting.
T-minus 1 minute, 30 seconds. Mark.
At the 31-second point, there will be a go for auto sequence start, which is a go in which the onboard computers take over the final minutes of the final seconds of the countdown. Coming up on the 1 minute point.
T-minus 1 minute.
T-minus 1 minute and counting. And the hydrogen burn igniters are on. They'll be fired at the T-minus 10 second point to burn off any residual hydrogen gas under the main engine nozzles and reduce the chance of an overpressure. T-minus 43 seconds and counting. Coming up on the T-minus 31 second point, mark. And we have a go for auto sequence start, switching control to the onboard computers. T-minus 20 seconds and counting. This T-minus 15, 14, 13, 12, 11, 10. We have a go for main engine start. 7, 6. We have main engine start. The motor's up and running. Plus 1, 2, 3, 4, 5, 6, 7, 8, 9, plus 10 seconds, 11, 12. We have a go for a shutdown. And We have safing in progress. If the computer had failed to command the shutdown on time, there were a number of safeguards built into the system.
1 and 2 are showing post shutdown and also engine 3. HDD.
All three engines are shut down.
Let's go for all 3 engines shut down.
Verify.
It appears everything has gone well at this point, and the team has started safing of the vehicle. The auxiliary power units in the process of being shut down. Water on the pad has been activated. This is water which will be cooling down the surfaces, ensuring that no fires could be started in those areas. It appears the planned firing, in which the main engines were run for an average of 20 seconds, actually the first engine to start was the last to shut down and should have run for approximately 22 seconds, while the one which ran for the shortest period would have been about 19.5 seconds.
And HDD, how are you looking for hydrogen detection? This is HDD. It looks real clean. There's no indication of hydrogen in the aft. Copy. Good.
OTC to say for you, shutdown complete. Copy that.